In this video, we're going to look at linear inequalities. So previously, we had explored the problem x plus 3 is equal to 2. And we had determined that x equals -1 is the solution. It's the solution because it makes the statement true. If we wanted to graph this solution, we would simply say -1 on the number line. We could simply, I'll do it down below here so it doesn't get in the way later. We could just put a dot right on the number line at -1. Typically, we don't even use a number line when we're working with equalities. But let's consider a new problem here. Let's consider the problem x plus 3 is less than 2. So this problem has a lot of answers that would make it true. So the solution actually contains an infinite number of values. Let's consider why. We could subtract 3 from both sides. And when we do so, we get that x is less than -1. So how do we show that? Since there are an infinite number of values that make this true, this is where the number line is very useful. Rather than trying to write down all of the possible things that would make it true, we can illustrate all of the possible answers by putting a circle that's open right at the number 1 and drawing a line to the left. We want all values that are to the left of -1. So for instance, -2 is less than -1 and would make this true. -7 is less than -1 and would make this true. -8.3215 would make this true. On the other hand, a number like 2 is not less than -1 and would not make this statement true. Also, the number -1 itself is not less than -1, so it doesn't make it true. And that's why we use the open hole right here. What that indicates is that we're not including -1. We're including everything that is to the left of -1, but we aren't including -1 itself. Now let's consider a slight variation on this that makes our life much more complicated. Let's consider the problem 3 minus x is less than 2. There are a couple of ways that we could go about solving this problem. One is to leave the x values on the left side, and the other is to move the x values to the right side. Let's first of all try the solution of moving the right values, the x values, to the right side. So let me write this here. 3 minus x is less than 2. So I'm going to add x to both sides. And that will leave that 3 must be less than x plus 2. Now I will subtract 2 from both sides. So 1 is less than x. How would we graph that? Saying 1 is less than x is equivalent to saying that x is more than or greater than, it's more proper mathematically, is greater than 1. So we would graph that. We're not including the 1. So we graph that by showing all of the points to the right of 1. But let's look at this another way, and this is where we will see the problem. Let us take 3 minus x is less than 2. Now, let's subtract 3 from both sides. And let's get that -x is less than -1. So let's multiply both sides by -1, or it's just easier graphically to show a division by -1, but multiplying by -1 will accomplish the same thing. And so we end up with x is less than 1. Uh-oh. We have a problem. X cannot be greater than 1 while simultaneously being less than 1. So clearly we have a problem. Both things cannot be true. So let's try to figure out which one is correct and then compensate for it. So the way we can figure out what is correct is to actually substitute values into the original expression. Okay, so let's try a little substitution and see which values actually make the original expression, which was 3 minus x, less than 2. So we know we have a problem around 1. So let's consider values that are on either side of 1. Let's consider negative 1. Let's consider 0. Let's consider 1 itself. Let's consider 2 and see what happens when we substitute those in. If we substitute negative 1 in to the left-hand side of the equation, we would get that 3 minus negative 1 is 4 is less than 2. Clearly, that is a false statement. So numbers like negative 1 make this statement false. If we substitute 0 in, we get 3 is less than 2, which is clearly false. So 0 cannot be part of the solution. If we substitute 1 in, we get 2 is less than 2, which is still false. When we substitute in 2, we end up getting that 1 is less than 2, which is true. And if we keep going and use, let's put the number 3 in. 3 minus 3 is 0. 0 is less than 2 would be a very true statement. So it looks like our original solution worked. Okay, notice that our original solution would have included 2 and 3. In fact, it included everything. It did not quite include 1, but everything that's bigger than 1 would be included, and everything that is less than 1 would be, everything up here would be excluded. So these would be excluded by the original solution, and these would be included. So the second solution had a problem with it. Okay, and the problem occurs right here in this step. When we divide by negative 1, we're getting the opposite of the left and right side. When you have an equality, it does not matter if you take the opposites of both sides, they're still equal. But when you take the opposites of two sides in inequalities, you actually need to flip the inequality. So there's a rule here that we can bring into play. If you divide or multiply by negative 1, this implies both sides, reverse the sign, reverse the inequality. If you do this, we will get the same answer either way. So if I had reversed the inequality, let me move this right out. Okay, so once I choose to divide by negative 1, I should have been reversing the inequality. In fact, right here, I should get rid of this sign. As soon as I divide by negative 1, I need to reverse the inequality, or conversely, I could move what was on the left to the right and what was on the right to the left, which is exactly what I was doing when I added x to the right-hand side in step 1 and subtracted 2. In the second step, I was taking things that were on the left and moving them to the right and making them positive, and things that were on the right, I was moving to the left. So you're doing the same thing by moving the sides through addition and subtraction as you are by multiplying and dividing by negative 1 in the second method. So let's just make sure that we remember when you're working with an inequality and you divide or multiply by negative 1, you need to reverse the inequality. In fact, I could extrapolate that to any negative value. If I were to multiply by negative 1/2, I could think of this as negative 1 times 1/2. Multiplying by 1/2 would not flip the sign, or reverse the inequality, I should say, but the -1 would. So you could combine it into one step. If you multiply by -1/2, you could do the division by 2 and reverse the inequality when you divide by the negative, or multiply by the negative. So remember to do that when you're working with an equality. It doesn't matter because switching the left and the right side of the equation doesn't change the balance of the equality.